Everything that you've ever known about babies is wrong. Well, maybe not everything. They indeed crawl, cry, poop, forget to breathe, and are just generally little mess-making nuisances. But one mystery has persisted throughout all of history. How are they made? I know what you're thinking. Obviously, storks deliver them to us. Movies, Greek tales, parental guidance, and even Baby Mario support this fact. The propaganda exists everywhere. After a lifetime of rigorous research, I'm here to uncover the truth once and for all. The truth that has been hidden from you all these years. Let's talk about sperm. Before we begin, I have with me my partner and the only person I can trust, Sebastian.
Hello, I'm going to give you an overview on the fertilization of sperm. So, sperm travels towards the ovum using its flagella, where eventually one sperm will make it into the membrane of the ovum, and after this it becomes impermeable to any other sperm, so pretty much there's no more that could go into the membrane. And after this, the sperm that makes it through loses its tail, and the genetic material of the sperm and the egg join together. The birth of sperm, spermatogenesis. So this spermatogenesis has two words: Genesis, creation story like the Bible, and then of course, sperm. So the first stage of the four is called the Golgi phase, where the spermatid is preparing to create the major parts of the sperm, the head, the midpiece, and the tail. And it's called this because the Golgi apparatus intensifies the entire first step. The second part is the cap phase, when the acrosomal cap is made, which is a membrane-bound compartment in the head of the sperm. The third stage is the formation of the tail. One of the centrioles of the cell becomes the tail of the sperm, and this is assisted by the manchette. The tail points away from the lumen. The last stage is the maturation stage. This is when division is ready and produces two secondary spermatocytes.
After spermatogenesis, the sperm just sits for a while somewhere in the body. However, at some point in the sperm's life, it must embark upon a great voyage. These sperm are in the minority, as over 60% of sperm are lazy little laggards who cannot even move. This sperm was prepared, however. It embroiders itself in a set of gel armor to protect itself from the acidic foreign land it will soon find itself in. Following contact with the different fluids in the female genital tract, a natural set of physical changes called capacitation occur for future ovum fertilization. These include changes to its movement patterns from straight lines to a fluctuation-like movement from of the head to the right and the tail to the left. An increase in membrane fluidity, alkalinization, occurs in the sperm's head, increasing its pH, making the already slightly basic cell even more basic. Camp chemical messengers and protein kinase are activated. A great exile of cholesterol is decreed, and modifications of plasma membrane lipids are made. The sperm propels itself through the dangerous environment of the female vagina and cervix. It dashes through the cervical mucus barrier, and it continues its expedition into the uterus, when all of a sudden, contractions propel the sperm upward into the fallopian tubes. If they can defeat their foes and prove their reproductive potential, they quickly proceed to the egg. As the experts demonstrated earlier, eggs aren't only God's gift to breakfast, they're also cells. They have no time to waste, after all, and cannot even mourn their fallen comrades. Of the 300 million sperm typically released during copulation, a mere 200 make it to the egg.
Stage 3 is egg transport. This begins at ovulation and it ends once the egg reaches the uterus. Following ovulation, the fimbriated, or finger-like, end of the fallopian tubes sweep over the ovary. After that, muscular contractions resulting from the movement of the egg create a forward motion. Time is ticking. The eggs are only capable of fertilization for 12 to 24 hours post-ovulation. Stage 4 is fertilization. Sperm contact with the egg occurs at the ampular isthmic junction. The enzymes within the acrosome, which we will discuss later, are released when it comes into contact with the egg's cumulus, breaking down the egg's coat, a crucial step towards the achievement of fertilization. The sperm's training during capacitation is paid off, and the egg cell membrane was penetrated. The cell membrane of the sperm and the egg chemically bind, and the sperm is sucked into the interior cytoplasm of the egg. The sperm's tail breaks off. Water now enters the now vulnerable sperm head, and a nucleus is formed by the sperm egg and the egg. Within 24 hours, the cell starts to divide and multiply, setting the stage for the creation of a human life. And so, the prophecy of life has been fulfilled.
Sperm have many unique organelles, specialized structures that help them work the way they do. Let's take a deeper look at each of these. Sperm cells are eukaryotic, means they have a nucleus. Located in the head of the sperm, the nucleus holds the DNA of the cell. The nucleus has 23 chromosomes, making it a haploid cell because it contains a single set of unpaired chromosomes.
Cytoplasm with nuclear vacuoles. Although scientists haven't fully agreed upon the origin and function of the nuclear vacuoles, it seems the more vacuoles are present, the less fertile the sperm.
Sebastian, how come your shirt's changed color and why are you so wet? The mitochondria, perhaps the sperm's most important organelle. Located in the body of the sperm, it produces energy for its movement, which is quite far for a single cell, while simultaneously doing other functions such as calcium regulation. Sperm have a lot of these. There's more mitochondria in sperm than seasons of The Simpsons, and there are too many seasons of The Simpsons.
The plasma membrane. The plasma membrane in sperm is a very important structure that functions to protect sperm against extracellular injuries and to respond to physiological challenges. It plays a crucial role during sperm capacitation, in sperm-egg interaction, and finally, in fertilization. It covers the entire sperm and contains many lipid rafts that move proteins from other large molecules through the cell membrane.
Biacrosome. Sperm without these are infertile. It develops from the Golgi apparatus of the mature sperm cells. It's an acidic vacuole that contains many polysaccharides and hydrolytic enzymes that help to break down various compounds via the introduction of water. The enzymes within the acrosome are released when the sperm cell comes into contact with the egg's cumulus, breaking down the egg's coat, which is a crucial step towards the achievement of fertilization. They also help to locate the egg through chemotaxis, causing the migration of the cell towards attractant chemicals associated with the ovum and away from repellents.
Manchette, or manchette, is a temporary skirt-like structure surrounding the elongating spermatid head that has a role in both nuclear shaping and protein transport while the sperm tail grows. The migrating cilia transition zone. In the spermatid, the centriole docks to the plasma membrane and forms a full-length cilium. After the cilium is formed, the transition zone and annulus migrate along the axonome.
Aquaporins. While not organelles, these vital transmembrane channel proteins act as a plumbing system for cells, allowing water to rapidly move into and out of a cell while preventing the passage of other solutes, including ions and protons. They have a role in osmoadaptation, the cell's ability to adjust to low and high water environments, and in protecting sperm cells from harmful swelling and the bending of its tail, which is important because if the tail bends, it may affect sperm motility through the female reproductive tract or through water to reach the egg. Sperms are subjected to various environments with rapidly different osmolarities and regulate their volume through tonicity by adjusting their water contents through aquaporin water channels. While osmotic changes are initially helpful to the sperm, kickstarting their movement, failure to adapt to the sudden changes in solute concentrations around the cell results in difficulties including the inhibition of motility, swelling, an unrelenting decrease in volume, and the impossibility of further survival.
Fibrous sheath. This is a unique cytoskeletal structure surrounding the axoneme and other outer dense fibers and defines the extent of the principal piece region of the sperm flagellum. It consists of two longitudinal columns connected by closely arrayed semicircular ribs that assemble from distal to proximal throughout spermiogenesis. The fibrous sheath is believed to influence the degree of flexibility, plane of flagellar motion, and the shape of the flagellar beat.
Sperm have centrioles that link the tail to the head. Among these, they contain atypical centrioles, two remodeled centrioles that are contributed to the zygote to be inherited. They reconstitute a centrosome that assembles the sperm aster and participates in pronuclei migration, the movement of the male and female pronuclei towards each other for fusion. Flagella, the tail of the sperm. It moves like a propeller, around and around. Flagella are long and push the sperm forward. A sperm can travel about 30 inches per hour. This may not sound very fast, but don't forget how small a sperm is. Sperm cells may be tiny, measuring only 0.005 centimeters from the end of their tail to the tip of their head, but they're most definitely mighty. For example,
one sperm is all it takes, swimming inside of me. Possibilities, one sperm is all eggs need. One sperm is all it takes, swimming inside of me. Possibilities, one sperm is all eggs need.
Now, let's take a closer look at the size of these little guys, proving there are some of the smallest cells in the human body. But first, we're gonna need to use math. Sperm measure a surface area of about 106.5 micrometers squared and overall mean volumes of 22.2 micrometers cubed. This simplifies to a surface area to volume ratio of about 4.8 to 1. Cell compartmentalization. CAMP pathways within sperm are designated only to required areas within the cell. They're primarily concentrated in or near the head of the sperm in the form of transmembrane adenyl-cyclases and of soluble adenyl-cyclases and protein kinase in the flagella of the sperm. These chemical messengers are designated because they are essential to the movement of each of their respective body parts. Without soluble adenyl-cyclases, sperm motility is never activated, and nor is sperm capacitation.
Permeability. The water permeability of human spermatozoa is of the highest reported for mammalian cells, meaning it's highly permeable to water. sperm cells measured at a filtrational permeability coefficient, LP, of 2.4 plus or minus 0.2 microns per minute per atmospheres at 22 degrees Celsius in conjunction with its low activation energy. Its permeability is likely high because it needs to go through a fair amount of water to reach the egg. However, sperm is selectively permeable in that it allows transport of glycerol and water within it, but rejects many substances that could be toxic to it.
Passive and active transport. Passive transport. Sperm are transported passively, or transported without the expenditure of energy, by testicular fluid from the seminiferous tubules to the head of the epididymis through the reedy testes and the efferent ductules. Since glucose is a large polar molecule, it can't pass through the lipid bilayer of the sperm's membrane. Thus, it needs carriers called glucose transporters to pass through in a process called facilitated diffusion for energy creation. This is a form of passive transport which does not need energy. Active transport. Sperm function is highly dependent on the exchange of ions between the cells and the medium in which they are immersed. This is under the control of a series of ion channels, exchangers, and active transport systems that operate at the plasma membrane of the cells.
When the father of microbiology, Antoine von Leeuwenhoek, first discovered sperm, he wrote a letter to the Royal Society of London, unsure of what to do with his findings. If your lordship should consider that these observations may disgust or scandalize the learned, I earnestly beg your lordship to regard them as private, and to publish or destroy them as your lordship sees fit. Destroy it, the lordship did, and they then founded a secret organization known as Stork, the Society to Obstruct Reproduction Knowledge, to prevent any information regarding sperm ever being brought to light. But why? Why would they go to such lengths so as to create an insidious fabrication that storks, of all creatures, deliver babies? Well, due to falling birth rates, Stork have kept the charade going to increase the population. After all, if people don't know how babies are made, they can't prevent parenthood. They've covered their tracks well and have done everything in their power to stop me and many others before me from unraveling their one great wicked sham. Who destroyed Van Leeuwenhoek's letter in 1677 when he tried to divulge the existence of sperm? Who made me late for my AP World History exam? Who messed with my Waze navigation that made it speak in a completely different language that resulted in a traffic violation? Who really assassinated JFK? Well, I'm not 100% sure on that last one, but the first three were definitely Stork, that's for gosh darn sure. Many of the most prominent historical figures were a part of the League. Even today, celebrities, politicians, and even trusted family members are a part of the League. Richard Nixon, Al Gore, Terry Crews, Mr. Beast, Buggy D. Clown, Woodrow Wilson, and even our very own Mr. Denston were at one point known members of Stork. I announce that I have documents with all my research and a list of all current Stork members that I will publish at this very moment. I will not stop until the perverted deceptions of Stork have been squashed once and for all. Sebastian, could you please hand it to me? The code to the safe is 80085.
No, I don't think I will. You fool, I was never on your side. Mission completed.